In the summer of 1942, the Crimean Peninsula trembled under the weight of the greatest artillery barrage in history. The German army was laying siege to the Soviet fortress city of Sevastopol. Thousands of guns were firing, turning the earth into a moonscape. But among the cacophony of mortars and howitzers, there was one sound that was different. It was a roar so profound that it shook the ground miles away, a thunderclap that signaled the arrival of something unnatural. This was the voice of Schwerer Gustav, Heavy Gustav. It was the largest gun ever built, a weapon of such colossal scale that it seems to belong more to science fiction than to history. It weighed 1,350 tons. Its barrel was over 150 feet long. It fired shells the size of small tanks, projectiles that weighed 7 tons and could punch through 100 feet of earth or 10 feet of solid concrete. To operate this single gun required a dedicated railway line, a custom-built crane system, and a crew of 4,000 men. Yet, for all its terrifying majesty, Schwerer Gustav presents us with a profound historical paradox. This weapon, the pinnacle of German engineering and the embodiment of destructive power, contributed almost nothing to the outcome of the war. In its only significant campaign, the Siege of Sevastopol, it fired fewer than 50 rounds in anger. Its total contribution to the tonnage of explosives dropped on the city was less than 1%. This story is not just about a big gun. It is about the seduction of scale. It is about how a nation can become so obsessed with technical perfection that it loses sight of strategic reality. Schwerer Gustav was not a failure of engineering. It worked exactly as designed. It was a failure of vision. It was a weapon built for a war that had ended 20 years earlier, a steel dinosaur wandering into the age of the airplane and the tank. To understand why Germany built this behemoth and why it ultimately failed, we have to look beyond the blueprints. We have to look into the psychology of a nation traumatized by the trenches of the First World War, desperate to find a technological solution to a strategic stalemate. Schwerer Gustav was the answer to a question that history had already stopped asking. The origins of Schwerer Gustav lie not in the ambitions of 1936, but in the nightmares of 1916. The German military leadership of the 1930s was composed of men who had served as junior officers in the Great War. They remembered the Battle of Verdun. They remembered the Somme. They remembered the horror of throwing waves of infantry against impregnable fortifications, only to see them cut down by machine guns and artillery. For these men, the ultimate enemy was not the French army, but the stalemate itself. They feared a repeat of the static, grinding war of attrition, where victory was measured in yards and millions of lives were wasted for nothing. This fear became a kind of strategic trauma. The German High Command was determined that the next war would be different. They would not get bogged down. They would have the tools to smash through any fortification, no matter how thick. This mindset drove the development of Schwerer Gustav. It was conceived specifically to defeat the Maginot Line, the massive chain of French fortifications along the German border. The Maginot Line was the physical embodiment of the stalemate Germany feared. It was a wall of concrete and steel designed to stop an army in its tracks. To the German planners, the only way to avoid another Verdun was to build a gun big enough to crack the Maginot Line open like an egg. In this sense, Schwerer Gustav was a psychological weapon as much as a physical one. It was a reassurance. It told the German generals that they had the power to dictate the terms of the battle. It was a promise that technology could overcome geography. But in focusing so intently on the trauma of the past, they failed to see the reality of the present. They were building a siege engine for a war of movement. The tragedy of Schwerer Gustav, if one can call the obsolescence of a weapon of war a tragedy, is that by the time it was ready, its target had become irrelevant. The gun was ordered in the mid-1930s with a specific mandate: destroy 7 meters of reinforced concrete or 1 meter of steel armor. This was the specification needed to penetrate the strongest bunkers of the Maginot Line. Krupp, the famous German armaments firm, took up the challenge. The engineering required was staggering. But while the engineers were calculating stress loads and propellant mixtures, the German strategists were rewriting the rules of war. In May 1940, the German army invaded France. But they didn't attack the Maginot Line head-on. Instead, they bypassed it. They sent their panzer divisions through the Ardennes forest, a region the French considered impassable for tanks. The blitzkrieg moved so fast that the massive fortifications of the Maginot Line were simply left behind. The French garrison sat in their impregnable bunkers, guns pointing east, while the German army raced west to the sea, cutting them off from behind. The Maginot Line was not destroyed, it was nullified. It was rendered strategically meaningless without a single shot from a super-heavy gun. By the time Schwerer Gustav was finally completed and tested in 1941, the campaign in the West was over. France had fallen. The bunkers it was built to destroy were now German tourist attractions. The gun was a masterpiece of engineering without a purpose. It was a hammer searching for a nail in a world that had switched to screws. This reveals a deep insight into the nature of military technology. A weapon system can remain tactically potent while becoming strategically obsolete. Schwerer Gustav could still destroy any fortification on Earth. The problem was that fortifications were no longer the decisive factor in war. The speed of the tank and the airplane had changed the geometry of the battlefield. Static defenses could be bypassed. The era of the siege gun was over, but Schwerer Gustav had just arrived. If the strategic vision behind Schwerer Gustav was flawed, the engineering that realized it was nothing short of miraculous. The Krupp engineers faced challenges that no one had ever solved before. They weren't just building a gun, they were pushing the limits of metallurgy and physics. The barrel alone was a masterpiece. Forging a single piece of steel 155 feet long and weighing 400 tons was impossible with the technology of the 1930s. So, they built it in 2 sections, joined together with a massive sleeve. The rifling inside the barrel had to be cut with extreme precision to spin a 7-ton projectile at supersonic speeds. The recoil forces generated by firing were so immense, thousands of tons of backward thrust, that a standard artillery carriage would have shattered instantly. The solution was a dual-track railway system. Schwerer Gustav was mounted on a chassis that spanned 2 parallel sets of railroad tracks. This distributed the weight and recoil over a wider area, but it also meant that the gun could only move on custom-built rail lines. It couldn't turn. To aim the weapon horizontally, the entire train had to be moved along a curved track. It was a mechanical marvel. The shells was a mechanical marvel. The shells themselves were technological achievements. Each armor-piercing round was taller than a man and weighed as much as 2 elephants. From a purely technical standpoint, Schwerer Gustav was a triumph. It worked. It could fire a projectile over 29 miles with devastating kinetic energy. But in the context of system warfare, it was a disaster. Modern war rewards mobility, redundancy, and flexibility. A weapon that can be quickly deployed, fired, and moved is infinitely more valuable than a weapon that takes 5 weeks to set up. A system of hundreds of smaller guns can saturate an area with fire, suppress enemy movement, and adapt to changing conditions. Schwerer Gustav was none of these things. It represented centralized destructive power in an age of distributed warfare. It was a static asset in a fluid environment. It required absolute control of the airspace above it, absolute security on the ground around it, and a logistical tail that stretched for miles. If a single rail line was bombed, the gun was stranded. If the weather turned, the setup was delayed. This mismatch between engineering perfection and strategic reality is the core failure of the weapon. The Germans built a perfect machine for a static world, but they were fighting a dynamic war. They optimized a single point of failure. In doing so, they demonstrated a fatal flaw in their military thinking, a preference for the spectacular over the practical. When Schwerer Gustav finally saw combat at the Siege of Sevastopol in 1942, it revealed another fundamental truth about weapons technology: the limits of scale. The gun fired 48 rounds during the siege. Of these, only about 10 landed within 60 meters of their intended targets. This inaccuracy was not due to bad aim or faulty equipment. It was due to the physics of extreme artillery. At ranges of over 25 miles, a shell is in the air for minutes. It climbs into the upper atmosphere, reaching altitudes higher than Mount Everest. Up there, the air is thin, and the winds are unpredictable. A gust of wind in the stratosphere can push a shell hundreds of feet off course by the time it lands. Furthermore, the sheer size of the gun introduced variables that smaller artillery pieces never encounter. The barrel was so long that it vibrated like a tuning fork after every shot. These vibrations were microscopic, but at a range of 29 miles, a fraction of a degree of deviation at the muzzle translates to a miss of hundreds of yards at the target. Temperature also played a role. As the gun fired, the barrel heated up. The propellant burned faster in a hot chamber, increasing the muzzle velocity and sending the shell further. The crew had to constantly adjust their calculations to account for the changing temperature of the steel. Barrel wear was another critical factor. The immense pressure and friction of firing a 7-ton shell eroded the rifling inside the barrel rapidly. After just a few dozen shots, the accuracy degraded significantly. The barrel had a lifespan of only about 300 rounds before it needed to be replaced, a process that required shipping the entire gun back to Germany. These factors combine to illustrate a deep principle of engineering. As scale increases, controllability decreases. There is a threshold beyond which making something bigger makes it less precise. Schwerer Gustav crossed that threshold. It was not inaccurate because it was badly built. It was inaccurate because it was too large. The Germans had engineered a weapon that could destroy anything it hit, but they could not guarantee it would hit anything. In a siege like Sevastopol, where the targets were massive forts and underground ammunition dumps, this lack of precision was somewhat mitigated by the sheer explosive power of a near miss. A 7-ton shell landing 50 yards away still causes an earthquake. But against anything smaller than a city block, Schwerer Gustav was effectively blind. This realization, that magnitude reduces precision, was a hard lesson. The Germans had assumed that bigger was always better. They believed that scale equated to dominance. But in the chaotic reality of the battlefield, precision is often more lethal than power. Schwerer Gustav was a sledgehammer trying to kill a fly. It made a lot of noise, and it certainly left a mark, but it rarely hit the target squarely. The true cost of Schwerer Gustav cannot be measured in Reichsmarks alone, but in what Germany didn't build because of it. In a total war, every resource is finite. Steel used for a railway gun cannot be used for a tank. Engineers designing a breech block cannot design a new aircraft engine. This is the concept of opportunity cost, and for Schwerer Gustav, the price was astronomical. The gun cost approximately 7 million Reichsmarks. To put that in perspective, a Panzer IV tank, the workhorse of the German army, cost about 100,000 Reichsmarks. For the price of one Schwerer Gustav, Germany could have built 70 tanks. Or they could have produced hundreds of trucks, critical for logistics on the Eastern Front. They could have manufactured thousands of standard artillery pieces, or enough fuel to keep an entire panzer division moving for months. But the cost didn't stop at the factory gate. Deploying Schwerer Gustav was a logistical nightmare. It required 4,000 men to operate and protect it. This included not just the gun crew, but also dedicated anti-aircraft units, security forces, and railway engineers. These were 4,000 soldiers who could have been fighting on the front lines, manning defensive positions, or driving supply trucks. The gun itself had to be transported on 25 separate rail cars. It took 5 weeks to assemble once it arrived at the deployment site. During that time, the crew had to build specialized tracks, reinforce bridges, and construct massive earthworks to absorb the recoil. All of this required thousands of tons of concrete and steel, diverting valuable construction materials from fortifications and airfields. Modern industrial warfare is a game of numbers. It rewards throughput, the ability to produce and field large quantities of effective weapons, not singular brilliance. A single superweapon, no matter how powerful, cannot cover a 1,000-mile front. It cannot be everywhere at once. It cannot replace the sheer mass of standard equipment needed to win a war of attrition. Schwerer Gustav consumed resources at a scale that could never be justified by its battlefield performance. It was economically irrational. In a war where Germany was already stretched thin, facing enemies with vastly superior industrial capacity, investing so heavily in a weapon with such limited utility was a strategic blunder. It was a vanity project disguised as military necessity. The decision to build Schwerer Gustav reflects a deeper flaw in German thinking, a preference for quality over quantity, for the spectacular over the practical. They believed that superior engineering could overcome numerical inferiority. But in a war of production, the side with the most tanks usually wins, not the side with the biggest gun. When Schwerer Gustav finally fired in anger at the Siege of Sevastopol in June 1942, it was supposed to be the decisive moment. The gun was positioned perfectly. The targets were massive Soviet forts with thick concrete walls. The conditions were ideal. Over the course of the siege, the German artillery fired approximately 30,000 tons of ammunition into the city. Schwerer Gustav contributed about 300 tons of that total. That is roughly 1%. Despite its legendary status, the gun was a minor player in the overall destruction of Sevastopol. The city fell not because of a supergun, but because of a coordinated assault involving hundreds of standard artillery pieces, relentless air attacks by the Luftwaffe, and determined infantry assaults. The German army used siege tactics refined over centuries, sapping, mining, and overwhelming firepower from conventional sources. They strangled the city's supply lines and battered its defenders into submission. Schwerer Gustav did achieve some spectacular hits. One shell reportedly penetrated 30 meters of earth and exploded inside an underground ammunition dump at Severnaya Bay, destroying it completely. Another shell cracked the concrete dome of Fort Stalin. These were impressive feats of engineering, demonstrating the raw power of the weapon. But they were isolated incidents. Most of the time, the gun was silent. It fired only a few rounds a day due to the immense logistical effort required to reload and maintain it. The barrel had to be cleaned after every shot. The temperature had to be monitored. The crew had to rest. Meanwhile, standard artillery batteries were firing thousands of rounds an hour, saturating the Soviet defenses and keeping their heads down. Schwerer Gustav was theater layered on top of systemic force. It was a showpiece. It boosted morale among the German troops who saw it, and it terrified the Soviet defenders who heard it. But in terms of actual military effectiveness, it was redundant. The job could have been done, and largely was done, by conventional means. The Siege of Sevastopol is often cited as the gun's greatest triumph, but a closer look reveals it as a hollow victory. The resources poured into Schwerer Gustav could have provided the German army with the mobility and logistical support it desperately needed for the upcoming campaigns in the Caucasus and Stalingrad. Instead, those resources were locked up in a steel behemoth that spent most of the war sitting on a railway siding, waiting for a target that justified its existence. The lesson of Sevastopol is clear. A weapon must justify its cost, not just in terms of destructive potential, but in terms of operational flexibility and strategic impact. Schwerer Gustav failed this test. It was a spectacular success in a narrow technical sense, but a strategic failure in the broader context of the war. If the Siege of Sevastopol was Schwerer Gustav's moment of triumph, the Siege of Leningrad was its moment of quiet failure. After the fall of the Crimean fortress, the gun was disassembled and shipped north to the outskirts of Leningrad, the second largest city in the Soviet Union. The plan was simple: use the supergun to crack the city's defenses and force a surrender. But by the time Schwerer Gustav arrived in late 1942, the strategic situation had changed. The German army was bogged down in a brutal winter campaign. The initial momentum of Operation Barbarossa had stalled. Leningrad was surrounded, but it was not falling. The Soviets had established a lifeline across Lake Ladoga, the famous Road of Life, keeping the city supplied. Schwerer Gustav was fully assembled and ready to fire. The tracks were laid. The ammunition was stockpiled. The crew was drilled. But the order never came. Why? Because the German High Command had shifted its strategy from assault to blockade. They realized that taking Leningrad by storm would be too costly in men and material. Instead, they decided to starve the city into submission. A massive artillery bombardment was part of this plan, but Schwerer Gustav was not suited for a blockade. Its rate of fire was too slow, its ammunition was too precious, its maintenance requirements were too high. Furthermore, the Soviet defenses around Leningrad were not concentrated in massive concrete forts like at Sevastopol. They were dispersed, camouflaged, and mobile. Schwerer Gustav needed a static, high-value target to justify its use. Without one, it was just a very expensive piece of metal sitting in the snow. This reveals something deeper about the nature of the weapon. Schwerer Gustav required strategic stability. It needed a fixed front line, a defined target, and a long period of preparation. The Eastern Front in 1942 and 1943 offered none of these things. The war was fluid, chaotic, and unpredictable. Soviet counterattacks could shift the front by miles in a single day. A static weapon like Schwerer Gustav could not survive in such an environment. If the front moved, the gun had to be disassembled and moved with it, a process that took weeks. So, the gun sat silent outside Leningrad. It was a symbol of German engineering prowess, but also a symbol of strategic inflexibility. It was ready for a war that wasn't happening anymore. The siege dragged on for years, but Schwerer Gustav played no part in it. It was eventually dismantled and sent back to Germany for refurbishment, having fired 0 rounds in the most important siege of the war. The story of Schwerer Gustav reaches its ultimate absurdity at the Battle of Stalingrad. As the German Sixth Army fought block by block through the ruins of the city, there were calls to bring in the supergun. But the reality of urban warfare made this impossible. Stalingrad was not a fortress. It was a sprawling industrial metropolis turned into a meat grinder. The fighting took place in factories, apartment buildings, and sewers. The distances were measured in meters, not miles. In this environment, a 7-ton shell is strategically absurd. Schwerer Gustav was designed to penetrate 10 feet of concrete from 30 miles away. Firing it into a city block would destroy a building, yes, but it would also destroy everything around it, potentially including German troops. The blast radius of a single shell was enormous. Moreover, the targets in Stalingrad were fleeting. A Soviet sniper team in a window, a machine gun nest in a basement, a tank hidden in rubble. These are not targets for a railway gun. They are targets for infantry, mortars, and close air support. Scale mismatch equals strategic waste. Using Schwerer Gustav at Stalingrad would have been like using a sledgehammer to kill mosquitoes. It would have consumed immense resources to transport and set up the gun, resources that could have been used to supply the Sixth Army with food, fuel, and ammunition. The weapon was simply too big for the war it found itself in. It was a dinosaur in a world of mammals. The agility and adaptability of the Soviet defenders at Stalingrad exposed the rigidity of German thinking. They fought a war of movement and improvisation, while the Germans clung to the idea of overwhelming firepower and static dominance. Schwerer Gustav never made it to Stalingrad. The logistical nightmare of moving it across the vast steppes of Russia under constant threat of Soviet air attacks and partisan sabotage was deemed too great. And even if it had arrived, it would likely have been useless. The battle was decided by encirclement and attrition, not by the size of the artillery shells. The failure to deploy Schwerer Gustav at Stalingrad is a testament to the weapon's inherent limitations. It was a masterpiece of specialized engineering that could only function under very specific conditions. When those conditions were not met, as they rarely were on the Eastern Front, the gun was nothing more than a burden. It highlights the danger of over-specialization in military technology. A weapon that can do one thing perfectly is less valuable than a weapon that can do many things adequately. The T-34 tank and the Katyusha rocket launcher were crude by comparison, but they were versatile, reliable, and available in massive numbers. They won the war. Schwerer Gustav, for all its power, did not. As the war turned against Germany in 1943 and 1944, the leadership increasingly sought salvation in technology. This phenomenon is known as the Wunderwaffe syndrome, the belief that a single, revolutionary weapon could reverse the strategic situation. Schwerer Gustav was an early symptom of this disease, but it was far from the only one. The Panzer VIII Maus is a perfect example. Weighing 188 tons, it was the heaviest tank ever built. Like Schwerer Gustav, it was an engineering marvel, boasting armor so thick it was virtually impenetrable, and a massive 128mm gun. But like the railway gun, it was strategically useless. It was too heavy for most bridges. It consumed fuel at an unsustainable rate. It was a slow, lumbering target for Allied aircraft. Only 2 prototypes were ever built, and neither saw combat. Then there were the V weapons, the V-1 flying bomb and the V-2 rocket. These were technological breakthroughs, precursors to modern cruise missiles and ballistic missiles. But they were deployed in a desperate attempt to terrorize civilian populations rather than destroy military targets. They consumed vast resources that could have been used to produce thousands of fighter aircraft or tanks. This obsession with wonder weapons reflects a deep psychological flaw in the Nazi leadership. Hitler and his inner circle preferred dramatic, singular solutions over systemic optimization. They believed in the power of the will, in the idea that German engineering superiority could overcome numerical inferiority. They ignored the mundane realities of logistics, production numbers, and reliability. Industrial war is not won by miracles. It is won by multiplication. The Allies understood this. They focused on producing vast quantities of good enough weapons: Sherman tanks, T-34s, Liberty ships. They overwhelmed the Germans not with superior individual machines, but with sheer mass. A Tiger tank might be better than a Sherman in a one-on-one duel. But if there are 10 Shermans for every Tiger, the Tiger loses. Schwerer Gustav fits perfectly into this pattern. It was a weapon designed to awe, to dominate, to break the enemy's will with a single, devastating blow. But war is rarely decided by a single blow. It is a grind. It is a contest of attrition. By investing so heavily in weapons that could not be mass-produced or easily deployed, Germany hastened its own defeat. For Schwerer Gustav to operate effectively, a specific set of conditions had to align perfectly. These conditions were rare in 1941 and virtually non-existent by 1944. First, it required absolute air superiority. The gun was massive and immobile. It sat on a fixed railway track, completely exposed to the sky. If the enemy controlled the air, Schwerer Gustav was a sitting duck. A single bomber could destroy it. At Sevastopol, the Luftwaffe dominated the skies, allowing the gun to operate safely. But as the war progressed, Allied air power grew, making such deployments suicidal. Second, it needed a stable front for at least 5 weeks. That was the time required to assemble the gun, build the specialized tracks, and prepare the firing position. In a fluid war of maneuver, 5 weeks is an eternity. Front lines can shift by hundreds of miles. By the time the gun was ready, the battle might have moved far beyond its range. Third, it required a fortress-level target. Schwerer Gustav was designed to destroy massive concrete fortifications. It was useless against dispersed infantry, tanks in the open, or mobile artillery. Such targets were common on the Maginot Line and at Sevastopol, but rare elsewhere. Most battles on the Eastern Front involved fluid engagements across vast open terrain. Fourth, it needed secure rail infrastructure. The gun moved on specialized double tracks that had to be built and maintained by thousands of engineers. This infrastructure was vulnerable to partisan attacks, sabotage, and bombing. Maintaining a secure supply line for the gun's massive shells and propellant was a logistical nightmare. These 4 conditions, air superiority, a stable front, a suitable target, and secure logistics, aligned only once during the entire war. At the Siege of Sevastopol, it was a perfect storm of circumstances that allowed the gun to shine, but it was a fleeting moment. After 1943, the strategic environment changed completely. The Soviet Union launched massive counteroffensives that shattered the German lines. The Allies bombed German rail networks relentlessly. The Luftwaffe lost control of the air. The conditions required for Schwerer Gustav vanished. The weapon was designed for a war that Germany hoped to fight, a war of methodical sieges and deliberate advances. Instead, it found itself in a war of chaos, retreat, and crumbling infrastructure. Schwerer Gustav required perfect strategic weather. The war produced storms. By the end of the conflict, the gun was a liability. It was constantly being moved to avoid capture or destruction. It was eventually blown up by its own crew to prevent it from falling into Allied hands. The wreckage was discovered by U.S. troops, a twisted mass of steel that served as a grim monument to the futility of the wonder weapon philosophy. The story of Schwerer Gustav is a masterclass in the perils of long development cycles during periods of rapid change. When Krupp engineers first put pen to paper in 1936, the world was a different place. Biplanes still dominated the skies. Tanks were slow, thinly armored boxes. The Maginot Line was considered the ultimate expression of military power. By the time the gun fired its first shot in anger in 1941, the world had been transformed. In those 5 years, military technology advanced at a breakneck pace. The speed of tanks doubled. Aircraft evolved from fabric-covered scouts into all-metal monoplanes capable of carrying heavy bomb loads. The doctrine of blitzkrieg, lightning war, had rewritten the rules of engagement, prioritizing speed, maneuverability, and combined arms over static fortifications. Schwerer Gustav was a weapon out of time. It took years to design, build, and test. By the time it was ready, the problem it was meant to solve, breaking the stalemate of trench warfare, had been rendered irrelevant by the very tactics Germany used to conquer Europe. The gun was not defeated by enemy fire or technical failure. It was defeated by the clock. This is a classic failure mode in military procurement. Nations often prepare to fight the last war, designing weapons to overcome the challenges of the past rather than anticipating the needs of the future. Schwerer Gustav was the ultimate answer to the trenches of 1916. But in 1941, the trenches were gone. The battlefield had become fluid, dynamic, and three-dimensional. The meta lesson here is that adaptation speed matters more than technical perfection. A good enough weapon that can be deployed quickly and modified based on combat experience is far more valuable than a perfect weapon that arrives 5 years too late. The T-34 tank was crude, uncomfortable, and mechanically unreliable compared to German engineering, but it was available in vast numbers when it mattered. Schwerer Gustav was a masterpiece of precision engineering, but it was a singular artifact, incapable of adapting to the changing reality of the war. As we look back on the twisted wreckage of Schwerer Gustav, abandoned on a railway siding in Bavaria in 1945, we are left with a profound sense of waste. This weapon, the largest gun ever built, fired fewer than 50 combat rounds in its entire existence. It consumed thousands of tons of steel, millions of Reichsmarks, and the labor of thousands of men. And for what? The answer lies in the illusion of extreme scale. There is a seductive logic to making things bigger. We assume that if a gun is powerful, a bigger gun must be more powerful. If a tank is strong, a heavier tank must be invincible. But in the complex system of modern warfare, this logic breaks down. Over-engineering narrows applicability. Schwerer Gustav was so specialized, so massive, and so complex that it could only be used against a handful of targets under ideal conditions. It lacked the flexibility to respond to the chaos of battle. A weapon that can only do one thing is a liability when the enemy refuses to cooperate. Maximum power reduces flexibility. The sheer size of the gun dictated its tactics. It could not move quickly. It could not hide. It could not be redeployed to meet a sudden threat. It forced the German army to build its strategy around the weapon, rather than using the weapon to support the strategy. Industrial war rewards replication, not singularity. The Allies won World War II not because they had better superweapons, but because they could produce, transport, and sustain massive quantities of standard equipment. They understood that 1,000 medium tanks are more effective than one giant railway gun. They embraced the logic of mass production and logistical efficiency. Strategic alignment matters more than technical perfection. Schwerer Gustav was a technical triumph. It achieved everything its designers intended, but it was strategically misaligned. It solved a tactical problem, penetrating heavy fortifications, that was no longer the decisive factor in the war. It was a perfect answer to the wrong question. In the end, Schwerer Gustav stands as a monument to hubris. It represents the belief that technology can overcome strategic reality, that sheer force of will can bend the laws of physics and economics. It is a reminder that, in war, as in life, bigger is not always better. Sometimes, the most powerful weapon is the one that fits the hand, not the one that crushes the earth. The largest gun in history rests now in the pages of history books, a curiosity and a cautionary tale. It is a testament to the skill of German engineers and the folly of their masters. It was a masterpiece of metallurgy. It was a catastrophe of foresight. And it remains, to this day, the weapon that arrived 5 years too late. History is filled with what-ifs. What if Germany had built more tanks instead of Schwerer Gustav? What if they had focused on jet fighters earlier? But these questions miss the point. The decisions made by the Nazi leadership were not random errors. They were reflections of a worldview that valued the spectacular over the sustainable. Schwerer Gustav was the physical embodiment of that worldview. It was a weapon built to intimidate, to dominate, to crush. But it could not adapt. It could not survive in a world where agility and resilience were the true currencies of power. Thank you for spending part of your day with us to explore this fascinating chapter of military history. If this story of engineering ambition and strategic failure resonated with you, we'd be honored to have you with us again.